Hey guys, it's Matt, and in this video we'll be talking about waves. We've probably all seen waves at a beach, but in a scientific context, waves are completely different. Waves can transport and carry energy without carrying any matter. And remember, matter is any substance that has mass and takes up volume. And if we remember correctly, energy has neither mass nor volume. So in this video, we're going to learn about two types of waves, longitudinal waves and transverse waves. Let's start with the longitudinal wave. This is what it looks like. Here's a 3D version. As you can see, it looks kind of like a slinky. It's all coiled up. There you go. And this is what a transverse wave looks like. It's sort of more two-dimensional. And in both waves, there are some basic characteristics of waves that you need to know. Wavelength, which is symbol lambda. Amplitude, frequency, which is characterized by a nu, like so. And speed. Let's start with wavelength. One wavelength is measured from any point on a wave to the next corresponding point on the wave. For example, let's say you want to take this point on a wave. The corresponding point would be this part. So this would be one wavelength right there. Now it's a bit different on a longitudinal wave because it's from one compression to another compression. So let's try and draw this out. Let's say this part is one compression because it's more close together, and this part is a second compression. The distance between these two right here is wavelength. Let's go on to amplitude. Let me erase all this. All right, so amplitude is basically just how big the wave is, but the measurement is again different for both wave types. On a transverse wave, the amplitude is from the midline to the highest or lowest point on a wave. So let's draw in a midline real quick. Let's say this is the exact middle of the wave. And we can find that the amplitude is just the highest point of the wave or the lowest point of the wave, like so, down to the midline. It can be that, or it can be this. They're both amplitudes. Now, on a longitudinal wave, the amplitude is the largest distance the particle will vibrate from the starting position. So let's say a particle is right here. And so when this wave vibrates back and forth, back and forth, back and forth, we're just measuring how far this one particle is going to move back and forth with the wave. And a wave with greater amplitude will carry more energy. Next, we have frequency. I'm going to erase some of this stuff. And frequency has a symbol nu, which sort of looks like a V. And it just means the number of waves produced in a given period of time. The standard unit is hertz. And 1 hertz is equal to 1 wave passing a fixed point in 1 second. And lastly, we have speed. The speed of a wave is defined as a distance to which a point on a wave travels per unit time. A common unit is meters per second. Meters per second for speed, and hertz for frequency. Now on a transverse wave down here, there are some other properties like the crest and the trough. The crest is just the highest point on the wave, so this would be the crest right there. And the trough is the lowest point of the wave, which would be right here. And there are multiple crests and troughs in the entire wave, so this could be a crest over here, this could be a trough over here. And thanks for watching this video. This is just part 1, and I'll upload part 2 so you guys can finish off the lesson on waves.